we have been celebrating a very nice meeting. Remember the first day in the welcome address, we made a comment about the probably would be a very special occasion, a very special Keystone meeting, because it was the number 10th in the series, and also we had this Nobel Prize celebration, and we commented that this was probably an indication of the maturation of the field, and also commented that we thought that this would mean an end, but also the end of the beginning, and therefore that this meeting would be important to really to show which is the current situation of the field. And I think that nowadays, today, after a few days in the meeting, we can, in my opinion, I think we can confirm that the meeting is very mature. It has been very good science, people from all over the world, going from molecules, mechanism, diseases, not yet cancer. There has been an area that has been very well covered in this meeting before, but also other diseases, cardiovascular diseases, immunity, neurodegeneration. So I think, well, we are, on my view, in a moment in the field of hypoxia research, which may be a new beginning. I mean, after a period that we are today, we are really closing it, okay, on my view. What do you think?
Yeah. Well, I think I'm perhaps one of the oldest in the field. I've been on the first meeting, on the Keystone meeting on the hypoxia, and I had some reserve at the beginning. I say, how could this be? I tell you, I will be going back very enthusiastic, because I can see the future clearly. I mean, all the new generation there, they're asking many questions, and I can see that the discovery by these three Nobelists, I mean, is going on and is flourishing. So for me, it's enthusiasm. And Keystone meeting, I've been also on the androgenesis meeting that we're mixing on metabolism, but this hypoxia meeting has to be continued. That's for clear. Yeah.
I think what struck me the most is that we're not talking about hypoxia as just a pathology anymore, but we're talking about it as physiology, and probably from the standpoint of therapeutics. So whether hypoxia can affect aging, whether hypoxia can affect mitochondrial diseases, whether it can affect regeneration, immunity. I think this is an important front in the field.
Yeah, definitely.
Yeah. No, I completely agree. I think we're building on the cornerstone of understanding the oxygen sensing response. And now that's moving forward into physiology and health and disease states. And that's across all cells, tissues, and organ systems. And that's why I think the field's also developing and bringing people in from different communities, because this is a fundamental pathway that has relevance in many different conditions and disease and cell states. And I think that's reflected by the population that are now joining the Hypoxia Keystone meeting. And I think it's also reflected in the fact that we've now got a great breadth of seniority of people within the field. So it's really exciting to see a mix of PhD students, postdocs, to senior PIs and Nobel laureates. Yeah. Very exciting.
I think that another point, another aspect to remark is that we all do experimental research. We work with cells, with molecules, with organs, but the field is very translational. Yeah. Truly translational. We really do research in experimental models in human tissues, but we already have clinical trials being done with the molecules that have been derived from concepts that have been generated in these meetings, in these Keystone meetings, to treat anemia, to treat cancer, with potential applicability to immune diseases, to cardiac regeneration, etc. So I think this is also a very good news, indicating that, okay, we are really truly translational. To do translational research is always the dream of all the funding agencies. NIH is all the time willing us to do translational research, but we are really doing it, okay? And not only, of course, in the scientific results and in the application, but the pharmaceutical companies are coming to the meeting. They have a lot of connections with scientists in our field. And as I said before, all these new products are being already in clinical trial. And this is a very promising and very stimulating for everybody.
There's still a potential of novelty coming from the young, where we heard about this chromatin change hypoxia. Yeah. There's so many things opening. So besides all these applications, in the clinic and the evolution, whatever. Also, we see the germ of new thing coming.
And I think how that speaks to sort of long-term reprogramming, and how that will fundamentally change, during the lifespan of an individual organism exposed to these multiple different challenges, and how the oxygen sensing response chromatin changes will actually imprint outcomes. I think that's...
I think along the same lines, some of the talks presented and some of the new model organisms such as the naked mole rat, it's a rodent that lives over 35 years, completely unheard of. And, whether this is because of the relative hypoxia that they live in or not.
No cancer.
Definitely has
no cancer.
No cancer, no cardiovascular disease, nothing.
Well, but now, oxygen being the most abundant element in the not in the atmosphere, the second most abundant element in the atmosphere, and one of the most abundant elements in the biosphere. In the field of hypoxia, the lack of oxygen, up to now we have been dealing with we thought that we were dealing with a specific signal transduction pathway, a specific diseases, a specific application, but now, you were talking before about that, oxygen, the field of oxygen sensing, the field of hypoxia, is affecting practically every cell function, and every cell dysfunction is being somehow modulated or affected by the concentration of the level of oxygen in the environment or in our bodies.
And I guess the broader sense of oxygen regulating enzymatic function out with the HIF PhD systems.
No, the enzymology has been central for the discovery and is continuing. And also, the life before oxygen arrived. I mean, this transition at the metabolism level is fascinating to see, like this Warburg effect was root already
that was
in the
interesting
bacteria with no oxygen. And then you see that after, I don't know, it's an evolution for me.
What is, in your view, the biggest challenges in the field moving forward?
Well, still on the sensor. I mean, there is an oxygen sensor, but has been a new thing by Bill Killing on the cysteine transport, cysteine sensing by PhD, by this. So this has not been exploited yet. Very nice paper that was published. So this is something we cannot predict. I'm sure it will be a big novelty. This for me was something, it has not been present here, but published.
I think that one of the biggest challenges is what's the translatability going to be like? Are we going after molecules, or going after actual environmental changes, or going after metabolism? And I think this is going to be the challenge.
Probably we need to go maybe more to physiology, to organ physiology, to go from the molecular biology to physiology and pathophysiology, not just in cellular models, but also in different models. I don't know, it's organoids and tissues, etc., that will really provide information about the actual role of the new oxygen-sensitive pathways that are being discovered right now.
That's a good point. Go ahead.
And then actually take it into human disease, to move beyond phenotyping in humans to actually fundamentally understand the consequence of differential activation of these processes in health and disease states so that we can intervene. So I think a real challenge is to look at this functionally.
I think the physiology is very important because we've all known for a long time that the mammalian fetus is hypoxic. And, we just focus on what oxygen metabolism is like after birth, but we forget that we existed in a hypoxic environment.
Definitely,
And, I think looking at the physiological aspect of this, not just the disease aspect, I think will be very important.
So, well, I think the field is in a very good situation, and the science is of the top quality, and we should congratulate about that. One point I wanted to also to introduce in this discussion is the environment that we have had. Okay, I think you mentioned a little bit about that before. I think not only the organization of the meeting has been, not us, the technical organization of the meeting has been fantastic. Having this hall near where the posters are, the dining room, etc. I think the organization, the technical is very good, but also the environment. I think the environment has been very nice. A lot of young people from different countries, from 19, I think, different countries, different cultures, different languages. We are speaking the common broken English, the common scientific language. Okay, the common not English, but broken English is the real scientific language. Okay,
it's okay.
And the young people have been participating a lot, asking many questions. And the environment is a lot of respectful relationship between the different people. Even you were asking a question that was complicated with a lot of mutual admiration between the colleagues. I think it has been in that respect, I think it has been a very, very good meeting on my view.
I think I saw a couple of postdocs asking Nobel laureates questions after their talks.
Yes.
Yes.
I would not have dared to do that.
No, the present, and also I think, I had to say, I didn't expect them, we know the Nobel laureate, they are excellent people, personally and scientifically, but I never expect them to be the full duration of the meeting. They are here, they are just open to everybody, interacting with everybody. We knew that they are very humble people, etc.
They are still on the cloud.
They are behaving in extraordinary ways, so the young people are taking advantage of that, and they are, interacting with it. This is great.
And that's where ideas come and cross-talk between different people with different interests. Developing new ideas and programs of research. I think it's really exciting.
I think classically, I have been attending these meetings already. This is the fifth I am attending this series of Keystone Hypoxia meetings. And traditionally, we have been talking a lot about acute hypoxia, responding in a few seconds to hypoxia versus chronic hypoxia that require gene expression and etc. No, I think in this meeting, I probably for the first time, I have seen that the fields are emerging. We have done, I think there have been important advances in the field of acute hypoxia, identifying not only in the arterial chemoreceptors in the carotid body, but also in neurons and in the pulmonary circulation, in the systemic circulation, identifying molecular mechanisms underlying the oxygen sensing, and some of these mechanisms are somehow similar or interact with the chronic hypoxia. So this is a field that is important for respiratory diseases, for respiratory depression, for anesthesia, etc. And in this field, I think it's going to be also advancing very much in the future and being more incorporated into the general concept of hypoxia. Okay, I think so. Would you agree with that, or do you think I am too optimistic?
No. I think
And I think from an immune point of view, actually, it's become increasingly apparent throughout the course of the meeting how hypoxia changes the immune environment, and that has consequences really quite broadly, both in the context of cardiovascular disease, malignancy, and of course in inflammation outcomes, and that's also starting to develop more broadly into understanding its impacts on both innate and adaptive systems and crosstalk between those different environments, and that actually this process is fundamental to how our immune cells respond and that they can be reprogrammed. And I think that's been a really exciting part of the meeting that's actually come out within each of the individual sessions that we've had.
Yeah, definitely.
Well, for me, this meeting with the hypoxia cover a big aspect of cancer. There's been many meetings and perhaps still some on metabolism and angiogenesis. Hypoxia was at the center. Now the metabolism is evolving with the immunity and to understand all the aspects. So I'm sure this will continue. We need still very strong basic. We still new model, like you say, for the apprehension of the cancer, the stem cell, and the more integrated thing. But this is a very important topic. Merging now the immunology, the metabolism, and the hypoxia center and vascular. So,
I think for me, the exciting part of this meeting was some of the talks that suggested a potential therapeutic aspect of hypoxia. For example, in mitochondrial diseases, and some of the investigators at Harvard are actually investigating whether they can treat patients with hypoxia, with mitochondrial, with very lethal mitochondrial diseases. Also applications, as we mentioned, the model organisms that are hypoxic, whether this affects aging, and my own work, which is focused on regeneration, whether hypoxia can enhance tissue regeneration in adult mammals. I think for me, mechanistically, this is not very clear yet, but at least we're starting from using hypoxia not as a pathological stimulus, but actually as a therapeutic
tool. Well, I think we can conclude that we have been very lucky being organizers of this, having the opportunity to organize one Keystone Hypoxia meeting with, I think, in the name of my colleagues. I think we can thank the Keystone Symposia organization for having invited us to organize this meeting. And I hope that we will continue with this series of Keystone meetings